Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows compiler. Today we will continue enhancing our creation of a dashboard application using the PowerBasic Windows compiler and RMChart. This was our application at the end of the last video. We've used RMChart to generate a chart with 3 regions, 2 pie charts and a line chart with 2 series data. This dialog is driven by a timer, triggering every 3 seconds, to redraw the chart at the bottom of our dialog. What we're going to do today is do some more enhancements on this dashboard. Let's have a look at the code. The first thing I would like to do is to put a watermark on the chart itself. A watermark is a good mechanism by which you can actually mark your chart to say who the owner of the chart is. For example, your company name, your department name, or even the project name. RMChart provides this out of the box. So if we go to where the dialog is actually set up, in here we have the controls on the dialog, followed by the subroutine which draws the chart on the dialog. What we're going to do is to add a piece of code after the DoTheChart call. RMChart provides a function that allows you to set a watermark. It takes a number of parameters. First of all, the actual text of the watermark, then the colour of the watermark, and followed by its Lucent value, its transparency, and then its alignment, and then finally the font size. So we're going to set some local variables up to hold that data. Now we'll populate those variables. The text in the watermark variable is an ASCII Z, and I've set it here to be 24 characters long, so it's big enough for the text we're going to populate it with. The text doesn't have to be all in one line, so I've added a control line feed character between the GSF software and the demo words. The colour in this case we're setting to be black. The Lucent value, or the transparency, is a number between 1 and 255. If you picked a value of 1, it would not be visible. If you picked a value of 255, it would be completely opaque. So we're setting a value of 10 so that's mostly transparent. The alignment we're setting to text center, so it's centered on the dialog. And the font size I'm leaving as 0, which will set it to its maximum size. So having set those values, we now have to tell RMChart to redraw the chart itself. So we're going to put an RMC draw command in after our setting of the watermark. And now we can try running our application. And there you will see the words GSF software demo on the chart itself. Having a watermark on your chart makes it very difficult for anyone else to use your chart and claim that it belongs to them. So what else can we easily do on this chart? In the moment our background is a fairly plain colour. We can use an image as the background itself. So we have a JPEG, Sea Sky JPEG, which we're going to put as the background. This can be quite easily done by using 2 calls to RMC functions. The first one is to change the control style. We need to amend this to set it so it will accept an image. So we're going to make a call to the RMC set control style function. It takes a mere 2 parameters, the handle to the RM control and the value for control style image. And the next call we make is to another function called set control background image. Again, it takes 2 parameters, the handle of the control, and the name and the path to the image you wish as your background. If we run our code now, you'll see we now have a background to enhance the chart even further. While these are merely cosmetic additions to your dashboard, they do help to improve the look. What we're going to do next is to emulate a drill down of one of the pie charts. While you're providing this dashboard possibly to senior management, while they can see the information on screen, they may want further information. For example, they can look at the number of incidents per division, and they can see that one of the divisions, for example the marketing division, has 11 incidents. So how can they actually drill down to that to see what the information is? What are the 11 incidents? This can be quite easily done. The code RM chart has provided you with allows you to click on any of the slices of the pie. If you hold down the Control key and press the left mouse button, you'll get a pop-up appearing. This little message box is showing you some information regarding what's been clicked on. It gives us some key information. It's telling us the region index is 1. This is the first region. It's telling you the series index is 1. There is only one series on this particular chart. And the data index is 1. In other words, you've clicked on the first slice of the pie, which is marketing. If we try clicking on a different slice, we'll see the region is still 1, the series is still 1, but the data index is now 2. So you've clicked on the second slice of the pie. It's also pulling back the absolute data value, which is 13, and the percentage data value, which is 21.31. We can find a piece of code in the application that's triggering this pop-up. We can then redirect that to another dialog. This pop-up is being triggered as a notification inside the callback function, the event handler. We can use this as a hook to our own dialog. We can launch a second dialog which will give the detail of these 13 incidents. So let's dip into the code and see where we can do that. If we look at the event handler, the callback function, if we scroll down, we will find the call to the control button down event. And in here, we are populating this variable with the CM lparam. The lparam holds a pointer to this particular structure, and this is what's pulling back all the information we saw in the pop-up. For example, we're calling this show info, and if we have a look at show info in this case is actually pulling back all the information from that particular structure. For example, there is the region index. So we can use that as a test to know which region the user has actually clicked on. What we'll set up is a drill down on the first pie chart, region number 1. So the first thing we'll want to do is to pull back the information for the region, the slice of the pie the user has clicked on, and the actual value contained in that slice. So we're going to create 3 new variables, one for region, one for slice, and one for the value. And we're going to populate those with the values held inside the t-info structure. We'll declare these variables in a moment. So to populate the values in these variables, we're using the @ sign, then t-info, dot, and then the element within that we're interested in. As this is a pointer, we're using the @ sign to take the value that's in this element and place it in our variable. We can use a simple select statement to allow our code to determine which region the user has clicked on, and we can direct the call to a specific dialog just for that region. So if the user clicks on region 1, this will be triggered. If they click on either of the other 2 regions, it will not. So we're passing 3 parameters to this new dialog we have not yet created. The first being the dialog handle, the second being the slice of the pie, and the third being the value contained within that slice. So let's declare these variables at the beginning of our function. Each of these is holding a long. As the value we're interested in is going to be a whole number, a long will do quite nicely. If we were wanting to pull back the percentage, then a double would be more appropriate. So let's look at creating this new dialog, which is going to show the list view. So here is our new function, the one we're going to use to display a list view on a dialog. It is taking three parameters: the parent dialog, the slice of the pie, and the value on that slice. So we're going to create a fairly standard bare dialog. This one will be centered on the screen as normal and will be titled Drill Down to Data. We're going to add a list view to this dialog. This will display the data which the user has drilled down to see. We can do this quite simply by using the control Add List View. We'll need to specify this constant at the beginning of our code, but we'll push on with the rest of this and we'll set that up in a moment. PowerBasic has some inbuilt list view commands to allow you to set the style of a list view, to insert columns, and to insert data. So for this list view, we intend having three columns: one for the division name, one for a department name, and one for a reference. Depending on the data you're drilling down to, you could of course display many more columns. This is purely an example to show you what we could do. We'll go back to the beginning of our code shortly and we'll set up these constants. I'm also using an enumeration here. We'll set that up in a moment as well. Having placed this list view on the dialog, we now need to populate it. First thing to do is to work out which division name are we actually looking at. What's the user clicked on? We know the slice of the pie, and we know that the getDivisionNames function we used in the last video will actually give us all the names. So we can use that function to populate a variable to get all the names of all the divisions in the incidents.csv file. And to get the actual division, we merely have to use the parse command to parse that based on the slice number. So strDivision will contain the name of our division. We'll create a function whose job it will be to populate that list view. We'll pass it a number of parameters: the dialog handle, the handle of the list view itself, the division name, and the value we've actually clicked on. For example, if the slice of the pie shows 15, we know there should be 15 entries in that data. This populate list view function can be used to pull data back from wherever it's actually sourced from. And our last thing to do in this particular function is to show the dialog modally. This will allow the user to peruse the data underlying the slice of the pie that they've clicked on. So there's a few things at the beginning of our code we'll need to set up. First of all, we'll set up the constant, which is the handle for our list view. We'll keep the format going that the RM chart created for us. It starts off with the handle of the RM chart itself being the WM user plus 1024, and then it's basically adding 1 to each of these. So we'll do the same, we'll add 1 to the ID print to give us the handle for the control itself. We'll also set up a little enumeration for the justification of the columns in our list view, either left, right, or center. We'll create the populate list view function in a moment, but we'll need to create the event handler for our new dialog. And this will be a callback function. So there are some basic things you would normally put in to most, if not all, callback functions. The first of these is the NC activate. This allows us to handle when the dialog is minimized and restored. Now for this particular list view, I'm going to reuse some code we did some time ago that allowed us to colour alternate lines of the list view different colours for readability. So we're going to use the WM notify event to pick up when data has been added to the list view. This makes use of the custom draw. We're going to work out whether the background of the row needs to be drawn or not. This code is fairly generic for list view boxes. The key bit in here is this function here which we're about to create. This is a function that works out whether the row needs to be background coloured or not. And this function is using the mod command, basically to work out whether the row is an even number or an odd number. So now we can create the populate list view function, the one that will actually put the data into our list view. This takes the 4 parameters we specified earlier: the handle of the dialog, the handle of the list view, the division name, and the number of rows we want in the list view, which is the value that's held in the slice of the pie the user has actually clicked on. So in order to emulate the population of this list view, we're just going to use a simple for next loop. We know the number of rows the user would expect to see is the value on the slice of the pie. So we're doing a for long r equals 1 to that value. And when you're populating a list view, the first thing you need to do is to do a list view insert item. This inserts a brand new row into the list view. So this first command is list view insert item. Then the dialog handle, the list view handle, the row we're actually putting it into, the column number, which in this case always starts at 0, and the text you wish to put into that column. In this case, we're putting in the name of the division. Having added this new row to the list view, we can now set the remainder of the columns. So we're setting the text on that row. And in this case, we're just putting the department details in. Obviously, if this was a real dashboard, we would be wanting to put specific details that the user would be expecting to see. And as our final column, we're putting in the ref followed by the row number. Before we try running our application, we want to comment out the call to the show info. If we go back to the callback function, the event handler, and we have a look in here, here is the call to the show info. Now we would normally in a production environment not want to show the user this raw data. So we try running our code now. Our dialog comes up quite happily, and as before, every 3 seconds it will regenerate the chart at the bottom. But on our first pie chart, if we hold down the Control key and press the left mouse button, this will trigger a call to the facilities, which has currently its 16 entries. And there are our 16 entries, all marked with the division we clicked on, department details, and a reference number from 1 to 16. And alternate rows are color-coded. So if we picked another slice, for example, the IT one, which has 10 entries, we would have 10 entries on the list. Now if we click on the second pie chart, which is region 2, hold down the Control key and click, nothing will happen because we have deliberately coded it so that this drill down will only happen for the first dialog. This allows you to have separate drill downs on each of your charts. As we'd set the chart at the bottom of the screen to change every 3 seconds to emulate at different points during the day, can we also do that for the pie charts? This can be quite easily done by adding to the 3-second timer. If we have a look at the callback function for the main dialog where the timer code exists, there is our timer being set up, and there is our timer being triggered to regenerate the data. So if we have a look at that regenerate data function, this is where the chart at the bottom of the screen is being regenerated, both Series 1 and Series 2. We can now do a change to our pie chart. I'm going to set up a local variable called long_slice, as we will step through each of the slices of the pie. Currently, we're not saving the data which we used to populate the pie chart, so we're going to create a new global variable to hold that. We'll set that up in a moment, but what I want to do is to put a little routine in place, which is a for next loop, to generate some random data to add on to the data that's already in there. So our new array is going to be called double incident data, as this is an array of double values. And we're going from slice 0 to the upper bounding of the array, as the data in this particular array starts at element 0. And we're quite simply taking the value contained within that slice, and we're adding onto it a number between 0 and 5. And once we've done that, we can then use the setSeries function to repopulate the underlying array which is used for the chart. And then when the chart control is redisplayed, our pie chart will be redrawn as well. So again, it takes a number of parameters: the handle of the control, the region, the data series, the array, and the upper bounding of the array. So this will be region 1, series 1, our very first pie chart. Before we run our code, we'll need to dimension this new array. So we'll set 2 up so we can always do the request data pie chart at a later point. Now, having set that up, we'll now need to change the original code which uses that array to populate it from the CSV file. So we nip back into the code which draws the chart initially, which is the doTheChart subroutine. Down here is a function which calls getDivisionValues. This populates the array with whatever is in the incident CSV file. We merely have to replace the array here with our new one. So when the code runs, we'll be using this array here to populate it with those initial values. Click compile to see we haven't missed anything. And if we run our code now, we should see after 3 seconds that the pie chart is also being updated. The numbers are getting bigger for different slices of the pie. As the pie chart is redrawn dynamically, should the largest slice change from red to green as it did a moment ago, then the chart automatically accepts that and displays the largest slice of the pie as being exploded. So what we've achieved today is we now have a pie chart which can be drilled down into, and the details shown in a separate dialog in the list view. We've also changed the background, and we've added on a watermark on the main chart itself. We've also made the first pie chart, the incidents per division, dynamically driven by the timer. So this way it could be updated dynamically during the day. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.